Good afternoon everyone. Myself Professor Swapnil S. Sudke of SND COE and Research Center Evla, working as Assistant Professor at Electrical Department. Now we will discuss the subject, that is Advanced Microcontroller and Embedded System. In this subject we discuss the unit number 4, that is interrupt structure and its programming. In this unit we discuss the topic, that is various codes used in PIC microcontroller and ADC, that is analog and digital converter, in detail. First of all, we see the code C code used in this microcontroller and ADC technology, that is in PIC microcontroller and analog to digital converter technique. This program basically works by displaying the running LED attached to RC0, RC1, RC2 and RC3 ports on the PIC 16F690 microcontroller. The speed of the running LED is controlled by the voltage value reads from the user stream port on the port RA0. This voltage value will be converted by the PIC ADC peripheral and passing the converted numeric value as the delay argument on the delay ms in bracket, then bracket complete, then function inside the loop. Then the user stream port basically works as the voltage divider circuit and provide voltage input level to the microcontroller analog port, that is AN0. Therefore, by changing the trimmer means we change the voltage level input, and this also will change the running LED speed. The user's switch works as a toggle switch. By pressing this switch once, the running LEDs will be switched to the blinking LEDs. Pressing once again will switch back to the running LEDs. Then for the ADC peripheral programming on the microchip PIC 16F690 microcontroller, we will focus on these two important registers. Is that all? Yes, you are right. Again, only two registers. If you curious of how this ADC setup being done in AVR microcontroller family, you can take a look at the similar project analog to digital converter AVR C programming posted in this blog. First one is ADC 0N0. Not ADC, it is first one is ADC ON0, that is AD control register 0. The function of this register is to control the microcontroller ADC operation, such as power on the ADC circuit, start converting, channel selection, ADC voltage reference selection, and ADC result format presentation selection. Then the CHS3, CHS2, CHS1 and CHS0 bits are used to select the ADC input channel. By setting all these bits to the logical 0 means we choose the channel 0 or AN0 pin 19 port, which connected to the user stream port on the PIC JAS 16F690 board. Then VCFG is the voltage reference bit. The voltage reference is needed by the ADC peripheral circuit to do the converting. By setting this bit to 0 means we choose the VDD, the peak 16F690 input voltage as the voltage reference. The 10-bit ADC result is presented in both AD RESH and AD RESL register as follows. That is, the ADC use the 10-bit two registers which is named as AD RESH and AD RESL register respectively. Then by setting the ADFM bit to logical 1, we use the right justified result. This means the higher 2 bits value will be placed in the AD RESH register and the lower 8 bits value are in the AD RESL register. By using the C-left shifting operation, we could get this 10-bit value as this following code. These codes are given by I delay is equal to AD RESL. / get the 8-bit LSB result. This code will give the 8-bit LSB result. Then I delay plus is equal to in bracket AD RESH, which is double less than 8 / this will get the 2-bit MSB result. That is, this code is useful to getting the 2-bit MSB result. Then powering the ADC circuit is simply turning on the AD on bit by setting it to logical 1 and to instruct the PIC microcontroller to start the conversion. We just turn on the go done bit logical 1 and wait until this bit turn off when the PIC 16F690 microcontroller ADC peripheral done. With the conversion, we use the C while statement to wait the ADC conversion as this following code. Then go done is equal to 1 / initiate conversion on the channel 0, while go done continue / wait conversion done. Then second one is AD con 1, that is AD control register 1. In order for ADC circuit inside the PIC 16F690 microcontroller to work, which is use the successive approximation method, it needs to be supplied with the clock for doing the conversion. This AD con 1 register is used to select the clock sources. Then because we are using the internal clock FRC of 8 MHz, then we set these ADC clock selection bits to ADC S2 is equal to 0, ADC S1 is equal to 1 and ADC S0 is equal to 1 as this following code. AD con 1 is equal to 0B 0011 0000 / select FRC for 8 MHz. If you are using the external clock with VDD greater than 3 volt, make sure you choose the selection below typical 4 microsecond, that is tad time needed by 10-bit PIC 16F690 ADC peripheral. To do the conversion as this following guide. For more information, Please refer to the PIC 16F690 datasheet. For example, if you use the external clock of 4 MHz in order for PIC 16F690 ADC peripheral to accurately converting the analog value, you only have two recommended choices. Either choose the FOSC of 8 bit or FOSC of 16 bits. The PIC 16F690 microcontroller ADC peripheral is also capable of generating interrupt when it finishes the conversion by setting the ADC interrupt flag ADIF bit to logical 1 in PIR1 register. But for the purpose of this tutorial, we will not use this facility. So we now here stop here. Thank you very much to all students.
आपल्याला बोल
कुठं
मेकॅनिकल एच